In this video, we're going to solve applications involving probabilities for normal distributions. All of these are technology-assisted problems, so we'll be using the calculator for all of these. In a survey of a group of men, the heights in the 20 to 29 age group were normally distributed with a mean of 67.3 inches and a standard deviation of 4.0 inches. A study participant is randomly selected. Complete parts A through D below. So second distribution, normal CDF, 67. Nope, sorry. We need to figure that out in just a second. Over there. We need 67.3 for our mean and 4.0 for our standard deviation. Part A asks us to find the probability that a study participant has a height less than 67 inches. So anything less than that, we're going to go to negative infinity. 67 here. And paste. And this is going to be 0.4701. You might ask, why did I go to negative infinity when you can't have a height that is less than 0? Because we need to get all that tail out there to the left. We need that z value to go all the way to the left there. So that's why I did that. There's not much of a difference anyways there, based off of how many standard deviations away 0 would be. I probably could have used 0 and gotten the right answer, but just showing you this is, remember, this is continuous. It goes all the way to the left to infinity, all the way to the right, because it's a normal distribution. So that's why I put that in there. All right, for the probability that a study participant has a height between 67 and 72, we want this to be 67 and this to be 72. None of those numbers change. And we have 0.4099. And now we want to know that they have a height more than 72 inches. So more than 72. Like that. And we have 0.1200 when we round to 4 decimal places. And identify any of the unusual events here. Explain your reasoning. Does anything that we looked for here have a probability of less than 5%? No, none of the events are unusual because they all have probabilities that are greater than 0.05. All right. In a recent year, total scores for a certain standardized test were normally distributed with a mean of 500 and a standard deviation of 10.8. So mean of 500, standard deviation of 10.8. And now we want to answer parts A through D below. Found the probability that a randomly selected medical student who took the test had a total score that was less than 491. This is probably the MCAT, but they probably don't want to say that this is the MCAT. That's usually what medical students take. So upper bound of 491. We want a number less than that. And so to 4 decimal places, this is 0.2023. And between 498 and 511, 498 and 511, it's going to be 0.4192 and more than 532. And we see that that's going to be our unusual event there, 0.0015. Can be most unusual for someone to get a score that high. So part C is unusual because its probability is less than 5%. The other two are greater than 5%, so they're not unusual events. The monthly utility bills in the city are normally distributed with a mean of $100 and a standard deviation of $13. Let's complete parts A through C below. The probability that a randomly selected utility bill is less than $68. So upper bound of $68, unbounded on the bottom, and we have 0.0069 when we round to 4 decimal places. Between 84 and 110, 84 and 110 is going to be 0.6699. And second distribution 2, more than $130. That. And that is going to be 0.0105. So both we weren't asked about this, but both A and C would be unusual events here because they both are less than 5%. B does not represent an unusual event here. Let's keep going here. Assume that a member is selected at random from a population represented by the graph over on the right. Find the probability that the member selected at random is from the shaded area of the graph, and assume that the variable x is normally distributed. So they have the area between 200 and 450 shaded with a mean of 505 and a standard deviation of 115. Let's just go ahead and use technology here. So number 2, lower bound is 200, upper bound is 450, mean is 505, and standard deviation is 115, and we get 0.3122. If we wanted to convert these to z values and use the table, we could do that. So 200 minus 505 over 115. 200 minus 505 divided by 115. And we would have to approximate that. And I'm just going to tell you that I know that my labs is going to get as exact with the answer as it can. So it's going to use technology, even if it doesn't say that it uses technology. 450 minus 505 divided by 115 here. Our second value is going to be about negative 0.48. And then we could pull up our z table here, negative 0.48, 0.3156 minus point, and then negative 2.65, 98765, 0040, 611, 0.3116. And you see that we're off quite a bit, actually, by using our z-table method, because we had to round both of these z values. So the calculator gave us a much better approximate, or a much better answer. And this is going to be the answer that my labs is most likely going for, even though they gave you the z-table here. So assume a member is selected at random from the population represented by the graph. Find the probability that the member is selected at random from the shaded region of the graph. Okay, so we're going to the right of 282 and to the left of 293. So second distribution, number 2, 282 to 293, and the mean is 268, and the standard deviation is 10. And this is 0.0745. Now let's use the normal distribution of SAT critical reading scores, for which the mean value is 509 and the standard deviation is 108. So again, just going to use technology here because I'm almost certain that's what my labs did, even though they gave us the table here. So mean is 509, and this is 108. And what percent of the SAT verbal scores are less than 675? So less than 675. And they want this as a percentage. So this is 93.79% when we round to 2 decimal places. And then we want to find greater than 525. 525 there, and 1 second EE99. And we would expect 44 point we would expect this percentage of the 1,000 people that took the test to be greater than 525. So I'm going to multiply by 1,000 because this is the probability. So I'm going to do x times p of x to get the expected value. I'm going to round that to the nearest whole number. So I would expect 441 SAT verbal scores would have a score of greater than 525. right? And that's it for this video. We'll come back next time and we'll talk about 5.3. See you for the next video.